Today we're going to be working with a little bit of imaginary numbers. It's very exciting. So the first thing I want to talk about is what exactly an imaginary number is. So an imaginary number is, we just refer to as the square root of any negative number. Because you're not allowed to take the square root of a negative number, it's imaginary. So in order to break it down so we are able to simplify imaginary numbers, we have to take the most simple imaginary number we can. And that's just the square root of -1. The square root of -1 we just refer to as I. So therefore we can rewrite any imaginary number then in terms of I. So the square root of -25 you can really think of as the square root of -1 times 25, which can then be broken up into the square root of -1 times the square root of 25. The square root of -1 is just I. And the square root of 25 is just 5. So you can write this as 5i. 5i means the square root of -25. It's the same thing. This is just the simplified way of writing it. So anytime you have a negative number under a square root, once you simplify it, it's going to have an I in the answer. That I has a negative built into it. So now let's try to simplify one that doesn't come out evenly. So the square root of -50, the first thing you want to do is pull the negative out and give yourself an I. So this is really I times the root of 50. Now we can split this 50 up the way that we've been doing all along the past however long now. So break this up into two numbers that have one of them's a perfect square, 25 and 2. So this 5 can come out and become 5i on the outside. And then the square root of 2 is stuck in there, so it's 5i square root of 2. Let's do that same process with 54. Once again, the first thing that you do is take out the negative and make it an I. So this becomes I root 54. That splits up into two numbers that are perfect squares. Let's try 9 and 6. So that 9 can come out and become a 3 on the outside. Stand next to the I. Then you're left with root 6. So that's our simplified version of that. Sorry about the bell, it's lunchtime. Okay, so sometimes the radical also has a variable under it. So for here, we have this x squared also. So you just have to simplify it the same way that we simplified everything in the previous section with radicals. First, let's deal with the negative. So that negative can come out and become an I on the outside. The square root of 4 is just 2. And the square root of x squared is just x. So this is just 2xi. That's the same thing as the square root of -4x squared. Now let's do the same thing with this one. However, this one, not everything comes out. So first, let's take the negative out. The negative becomes an I on the outside. Now 12 can split up into 4 and 3. So the 4 can become 2 on the outside. That 3 is going to have to stay in the radical because it's not a perfect square, it can't come out. Now still this x cubed. You need a pair of x's to come out. So if you want, you can think about it as x squared and x. So x squared can come out of the radical. The square root of x squared is just x. And then this guy, this x is left in the radical because it's not a perfect square. So this breaks up into 2xi, then root of 3x. If you want to write this, it's not supposed to be that far apart. It was a little exaggerated. These are multiplied together. So now let's just talk about numbers that are not just imaginary, but numbers that are complex. A complex number is just an imaginary number and a real number kind of put together. So we write complex numbers of the form a plus bi, where a and b are real numbers. A is called the real part of this complex number, this part, and b is called the imaginary part because it's connected to the I, the imaginary number. So now let's look at this example. This is an imaginary number 3 minus 4i. So it has a real part. Here our a is 3, and the imaginary part is -4, b. So here's another complex number. Here the a is 10, and the b is 1/2. It's just a combination of both a real part, 10, and the imaginary part, the 1/2i. So let's remember that all I equals is the square root of negative 1. So let's try to think about what I squared would equal. Remember that I is the square root of negative 1. So if I squared, square root of something squared is just that number. So I squared is just negative 1. This is helpful because it allows you to simplify anything where you have powers of I in it. So now I cubed, if you would like to think about it as I squared times I squared is really negative 1. So I cubed is negative I. This becomes negative 1. Now let's talk about I to the fourth. I to the fourth is really I squared times I squared. I squared times I squared is negative 1 times negative 1. So I squared times I squared is just I. Oops, that's totally not right at all. Negative 1 times negative 1 is 1. Woo! I'm at the lunch, like everyone else is right now. Alright, so I to the fifth is I to the second times I to the second times I, if you want to think about it that way. So I to the second is negative 1. I to the second is also negative 1. And then I can't do anything with it. It's just I. Negative 1 times negative 1 is 1 times I is just I. The other way that you can think about this is I to the fourth times I. You know that I to the fourth from the previous problem is just 1. So this is just 1 times I, which is just I. So if you look, there's a pattern here. I equals I. I squared equals negative 1. I cubed equals negative I to the fourth equals 1. I to the fifth equals I. There's a pattern forming here. I to the sixth is going to equal, I'm going to leave that for a question for you for your video. So now let's try to simplify some more of these. So all we're doing to simplify is just combining like terms and using the fact that I squared equals negative 1. So 9I minus 6I, here I have 9 i's, I'm taking 6 of them away, so I just have 3 i's left over. Then here, I have 3I squared, so from the previous slide we learned that I squared equals negative 1, so this just equals negative 3. Here, I have this 1 has no like terms. It looks like this 3I has no like terms, and that this negative 4I squared has no like terms. However, remember that I squared is really negative 1. So if I rewrite this I squared as negative 1, then this can be simplified. 1 minus 3I minus 4, I squared is really negative 1. So 1 minus 3I, negative 4 times negative 1 is positive 4. And if I combine like terms here, I have 1 plus 4, that's 5 minus 3I. I just get a complex number. You don't have to write out all these steps. If you're able to quickly see that I squared equals negative 1 from the beginning and simplify this, that's fine. I'm just trying to show you how it works. So now let's try to simplify this one. Here I have I cubed. If you want to remember that I cubed just equals negative I, that's fine. If you want to rethink about this as I squared and I, remembering that I squared is negative 1, that's fine too. 4 times negative 1 is negative 4, and this I is still left over. So now let's try to simplify one where everything already has like terms. So here I just have 4 terms that are all like, they're trying to be combined with addition, so you can just combine them all up. So 3I plus 4I is 7I. We're just going to do it in 2 steps to make it a little bit easier. And then here I have I minus 5I. I have 1I, I take 5 away, I have negative 4I. Now I'm going to combine 7I and negative 4I, and I get 3I. That's it. So now let's try to get into ones where we have multiplication going on here. So here I have 4I, the quantity squared. That really means 4I times 4I. Well, 4 times 4 is 16. I times I is I squared, and I squared is negative 1, so the 16 becomes negative. Now, let's talk about this one. Here, I have these 2 complex numbers multiplied together. So just like I would have to do if I had 3 plus x and 2 minus 5x, I would have to FOIL this out. I'm going to do that same process now with the foiling of these complex numbers. So here, 3 times 2 is 6. 3 times negative 5i is negative 15i. I times 2 is 2i. And I times negative 5i is negative 5i squared. Now here's the part where I'm going to use complex numbers that makes this a little bit different from regular foiling with polynomials. So here I squared is equal to negative 1. So this term becomes plus 5 instead. So I have 6 minus 15i plus 2i plus 5 instead of minus 5i squared. If you're able to simplify this all in one step, go ahead. I'm just trying to break it down so that you see where everything's coming from. Now you just combine all your like terms. 6 and 5 are like terms. They become 11. Negative 15i and positive 2i are like terms. They become negative 13i. And that's your answer. You have a complex number. The real part is 11. The imaginary part is negative 13. Oh, I'll tell you my joke of the day now. Okay, so our joke of the day is, what did the digital clock say to his mother? Look, Ma, no hands. Okay, so, that was the end of our presentation anyway. Perfect. Also, our student of the day is Maria because I made her sit outside and take her test while I was recording this presentation. Sorry, Maria.